Good morning to one and all present here. My name is Krrish Bhardwaj. I am a first year student from Charotar University of Science and Technology, and today I am going to talk about that is digital systems in satellite and space communication. So, let us begin. First we will start with the basics that what is the meaning of satellite communication? Satellite communication is a type of wireless communication that uses satellite in space to send as well as receive signals, enabling communication over long distances. Now we will take a glimpse of why these satellite communication are so important. So it helps us in global connectivity, broadcasting, GPS. That is, whenever we want to go from one place to another, we use this Google Maps. So with the help of the satellite communication, we are doing so. Also, there is a weather forecasting that is allows for accurate weather predictions and disaster monitoring. So next, we will move toward the key components of satellite communication. So first one is space segment, that is satellites. Satellite in space send and receive signals for communication. Types include communication satellites, weather satellites, and GPS satellites. So second is ground segment, that is ground stations. So ground stations on the earth send as well as receive signals to from satellites. They also track satellite positions. So third one is user segment. That are the devices. Devices like satellite, phones, TVs, and internet receive that uses satellite signals. So next one is that is digital system overview. So we will start with what is digital system. So a digital system uses binary code. So everything that we perform, whether on the laptops or whether on the computer, they uses binary code, or it only understand that is binary language, that is in the form of 0 and 1. So everything we need to convert into the binary code that system understands or process the information. So it is the backbone of the most modern communication systems, including satellite communication. So let us look how digital system works. So first one is encoding, that is convert the information like a voice call or a video into binary code, that is 0 and 1, as I earlier said. So second one is transmission, that is the binary data is sent over communication channels like satellites. And the third one is decoding. Obviously, we could not understand the binary language, so we need to decode this into our own understandable language. So let us look at the receiver turns the binary code back into the original form, that is the voice or video, for the user to understand. So this is how it works. So the third one is that is role of digital system in satellite communication. So we will start with what is modulation. So modulation is the process of changing a signal like a radio wave to carry the data. Okay, so we will talk about QPSK, that is quadrature shift keying. So here the word keying is that we are sending the data, we are putting our data sets to the computer itself. So let us look at a common method in satellite communication. It's said 2 bits. Okay, so we cannot send the whole bit all in a together. We have to send this in a bit by bit system. So data at once, making it efficient and fast. And the third one is BPSK, that is binary phase shift keying. So a simpler technique that sends 1 bit at a time. It is used for simpler or lower speed. If we want to send the data in a lower space or get full data of the transmission, so we will use BPSK. So this is how it goes. So the third one is that is error correction. During transmission, data can get damaged. Obviously, there are some ways that weather conditions or distances are not in our favor. The weather conditions can also get bad and the data can be lost. So for this, we have the use read Solomon codes technique is one of the example of a method that checks and corrects errors, ensuring that the received data is accurate and complete. So if I want to explain this, so we can understand this in a such a way that if I want to send a message which consists of 10 words, and before just sending the signal or the message, I have added 5 words which are based on those 10 words and which contains the data of those 10 words and which are made through it. So by any chance, if our the whole main 10 words get damaged or not reached to its final destination, we can also redeem those data with the help of those those 5 words which we have sent later. So this is how read Solomon codes works. So next move on signal processing in space communication. So the first one is compression, that is digital system reduce the size of data before transmission to save bandwidth, less space needed for the data. Obviously we need to minimize the data. So second one is encryption, that is digital system secure the data so that only authorized users can access it. This is essential for the privacy in communication. And the third one is error detection. We have already talked, but let's look at here forward error correction, that is FEC. Add extra data to help fix errors in the transmission. As I earlier talked about, that we are sending those 5 words in the example. Let's move on. So the next one is satellite system architectures. These are nothing but these are type of satellites which we have proficiently used. So first one is geostationary satellites, that is GEO. Here is a parameter that 35,786 kilometer is the range in which the satellite can revolve. It is used for mainly TV broadcasting, internet and weather forecasting data. And the second one is low Earth orbit satellites, LEO. The parameter is 500 to 2000 kilometer above the Earth. Provides services like mobile communication and remote sensing. And the third one is medium orbit or satellites, that is MEO. These satellites work between the GEO as well as LEO, and these are used in for GPS systems. Let's move on. So the next is digital system in space exploration. So the topic is space mission communication. So digital systems enable communication between spacecraft and Earth, supporting missions like Mars exploration or satellite launches. Second one is telemetry system. Obviously, we need to look at the spacecraft conditions like temperature and pressure also to so that our spacecraft is working efficiently or not, or if there is any problem, so we can catch it and detect it and solve it. Next one is navigation system. That is, digital systems help spacecraft navigate accurately using GPS and other technologies. So next, move forward. So another one is advantages of digital communication and satellites. So higher capacity. Digital system can send more data in the same amount of space or bandwidth. Next one is better quality. Digital signals are clearer and less likely to distorted by noise compared to analog signals. And the third one is security. Digital systems can encrypt data, keeping communication secure and preventing unauthorized access. Let's move on. So here are some future trends in digital systems for satellite communication. So first one is that is 5G and beyond. New digital systems will support faster speeds and lower latency for global internet and mobile communication. Second one is small satellite networks, that is CubeSats. Smaller and cheaper satellites are being used for better global coverage and especially in remote as well as undeserved areas. And the third one is advanced modulation and coding. So new techniques with help of send data faster and improve signal reliability, making satellite communication even more efficient. So the final thought of mine is that as technology evolves, digital systems will continue to expand and possibilities for space exploration and global communication, and they play a crucial role in satellite communication, enabling reliable and secure and efficient data transmission. Thank you.